This is for Algebra 1. This is Parabolems Galore. Let's start with a quick reminder of how to tell if a table represents linear or quadratic data, or possibly neither. When you have a table, it's going to have x and y values. And what you do to figure out if it's linear or quadratic is you do your first difference. 6 minus 2 is 4. 10 minus 6 is 4. 14 minus 10 is 4. When this number right here is the same, it is linear. If this number is not the same, but you go through the process again and this number is the same, it is quadratic. Transformations to quadratic functions that we've talked about really quick. If it is a number added or subtracted at the end, it's going to go up or down. If it is trapped in here with the x, it is going to go left or right. If it is a number in front of the x squared, it is going to get wide or narrow. And if it is a negative in front of the x squared, it is going to flip. You need to know these transformations. You've got to memorize them. So looking at your worksheet, how do the graphs of f of x is equal to x squared plus 9 and g of x is equal to x squared minus 10 relate to each other? Okay, first of all, don't let the f of x and the g of x bother you. It's the same thing as saying y is equal to. Okay, it's just using different letters. Don't worry about that. So we're going from x squared plus 9 to x squared minus 10. So we're noticing that the difference is at the end. So if it's at the end, we're talking about an up-down change, right? At the end, we said it was either going to go up or down. So look at your answer choices. It's not going to go to the right or left. So is f of x, which is plus 9, 1 unit above g of x, or is it 19 units above? Well, you got to realize that you've got one way up here at positive 9 and one way down here at negative 10. So you're going to go up from 10 to 0, from 0 to 9. So it's going to go up 19 units. So your answer here is B. Number 2, we have y equal x squared plus 8. What describes the shift? If we change the 8 to a negative 2, that means it becomes x squared minus 2. Well, we went from a positive 8 to a negative 2, so that should tell me that it's going to send me down. Okay? I was at positive 8, now I'm at negative 2. So I'm going down. I've got to get 2, 0, which is 8 moves, and then I got to get 2 further. 8 and 2 gives you 10. So it goes 10 units down. Which function below is the parent function for a quadratic? The equation that is quadratic is x squared. So they've shown us the graph of x squared plus 1. And they want us to, first of all, graph negative x squared minus 3 on the same graph. And describe the transformations. Well, let's describe first. That negative is going to make it flip. That minus 3 is going to send it down 3. If you need to put it in at your calculator at y equal, that's fine. We're going to have negative x squared minus 3, negative x squared minus 3. Then you're going to have to look at your table and get some points. Negative 1, negative 4, 0, negative 3, 1, negative 4. So negative 1, negative 4, 0, negative 3, and 1, negative 4. And it's going to look something like this. Did it flip? Did it move down? Yes. The way you know about the down is we're talking about the vertex, okay? Compare your vertex. Give an appropriate domain in range. Okay, this is going to be for the new one. Remember, it's going as far as it can left and right, and so the domain is ARN. Your range, the low point has arrows, so you're not going to put a number there, and you're going to start with y is less than or equal to. The high point is right here, which is negative 3. Use a table of values to show through finite differences that it is quadratic. This is where we were doing our subtracting the y values the other day. So negative 10 minus negative 9. Be careful on this because of all those negatives, take your calculator. It's the second one minus the first one. So negative 10 minus negative 9. And you get negative 19. So then you have negative 13 minus negative 10. Negative 13 minus negative 10. And I see a problem in the first one. I'm going to redo it in just a second. Negative 3. See if you can tell what my problem was. When I did negative 10 minus negative 9, what happened? I didn't get my negative in there. So I'm going to go second enter, and get that back. I'm going to come over here, and I am going to insert a negative, and that's going to change that. Let's clear that. Still isn't looking right, is it? Let's just do it over. Negative 10 minus negative 9. See how important it is to make sure you get all the keystrokes in there, right? And it is actually negative 1. So then we're going to have negative 18 minus negative 13, and that's negative 5. Negative 25 minus negative 8, and that is negative 7. Negative 24 minus negative 25, and that's negative 9. And negative 45 minus negative 34, and that's negative 11. So it's obviously not linear. But now when we do our second differences, negative 3 minus negative 1 is negative 2. Negative 5 minus negative 3 is negative 2. Negative 7 minus negative 5 is negative 2. Negative 9 minus negative 7 is negative 2. And negative 11 minus negative 9 is negative 2. This right here shows that it is quadratic. This is what we learned the last 2 days, actually. Going to the next page. Pablo wants to build a pen for the pig he's raising in his ag class. He only has 36 feet of fencing. What dimensions can Pablo use to give the pen the maximum area? Organize your information into the four-corner model below. So we're going to start by figuring out the area for each time. We're going to fill in this table. If your length is 1, your width is 17. Multiply them together because remember area is length times width. If your length is 2 and your width is 16, it'd be 32. 3 times 15 is 45. Now, where are they coming up with what the length could be? I'm going to assume that this is 14, right? And so then 4 times 14 is going to give you 56. If it is 5 here, it's going to be 13 here. And 5 times 13 is going to give you 65. If it's 6, then it's going to be 12, and it's going to be 72. So if it's 7, am I going to go to 11? It's going to be 77. 8 by 10 would be 80. 9 by 9 would be 81. 10 by 8 would be 80. 11 by 7 would be 77. 12 by 6 would be 72. Now we're trying to find the maximum area. If I look at this table, which one is the maximum area? Right here. So it has the dimensions of a 9 by 9. So how could you show that as a scatter plot or a graph? Notice all of my numbers here are positive, so I don't have to do the full graph. Figure out what you want to count by. You got to get up to 12. Actually, you got to get up to 17, right? You've got, this is going to be your X, and this is going to be your Y. So if your length is 17, your area is 1. If your length is 16, I'm sorry, it's not 1, it's 17. You're using your table. 17, 17, so you can go over 17, up 17. You're going to go over 16, up 32. So I didn't count good there. You got to plan ahead, right? This is where you got to look. I've got to get up to 81. So I probably want to go 10, 20, 30, 40, 50, 60, 70, 80, 90. So at 17, it's 10, not quite 20. At 16, it's 10, 20, 30. At 15, it's going to go 45. At 14, it's going to go 56. At 13, it's going to go 65. At 12, it's going to go 72. At 11, it's going to go 77. At 10, it's going to go 80. At 9, it's going to go 81. At 8, it's going to go 80. At 7, it's going to go 77. At 6, it's going to go 72. So what have I basically created? Looks like a parabola to me. So the dimensions for the maximum area using a verbal. Okay, when they want verbal, it's a sentence. Dimensions are always talking about in length and width. We said that length of 9 and width of 9 give a maximum area of 81. There's a verbal description. We just wrote a sentence, okay? Domain and range. Look back up there at this graph. Remember, domain and range normally would be ARN, but length and width cannot be negative, okay? So my domain, the smallest it could be would be 0 is less than or equal to x is less than or equal to what was the largest it ever was. Looking at your table 17. Your range, the lowest that your area could ever be would be 0 is less than or equal to y is less than or equal to the largest area we ever had from the table was 81. Now, I really don't like the way we wrote this because what did they give me? A table. When they give me a table, it should really be a list. 0, 1, 2, ... 17. Range 0, 1, 2, ... 81. Except it's not 0, 1, 2 probably. You would probably need to actually list the numbers we had here. Okay? I'll be easy on you for this because this is new. Going to the next page. Parabolems galore. They've given you a table and they want an equation. You're going to put your numbers into stat. You're going to go stat, calc. This time you're going to do 5. It's not stat calc 4, it's stat calc 5 because they are quadratic. So I went to stat, edit, and I put the points from this table in my calculator. Now I go back to stat, I go over to calc, and I choose number 5. It should say quadratic regression because we're doing quadratics. Now enter. The number with a goes with x squared, the number with b goes with x, and the number with c goes as a constant. Ignore the r squared. So this is going to be x squared plus 4. Y is equal to x squared plus 4. So now go back to your calculator and do the next one. This one, the calculator should give you a of -2, b of 0, and c of 0. And so that is simply y is equal to -2x squared. So now pause it and take a minute and put the next one in. This one gives me an a of 3, a b of 0, a c of 0. So y is equal to 3x squared. Then for the last one, this one gives me a of 1, b of 0, and c of -1. So y is equal to 1x squared minus 1. If you put the 1 in front of the x squared, that's okay. It's not required. Looking at the last page, we have problems 5 and 6 using the graph. What transformations occur on the parent function? Look at your graph and see what happened. Well, my vertex went from the origin to 3, so it went up 3. It did not go left or right. If I go over 1, up 1, I'm on the line, so it did not get wide or narrow, and it did not flip. So it's y is equal to x squared plus 3, because up 3 means you added at the end. Okay, this one flipped. It's still at the origin. It did not go left or right either. And if I go over 1, down 1, I'm on the line. So the only change was the flip. Y is equal to -x squared. This takes you to your assignment. If you have any questions, call me over.